The greenhouse effect. We've all heard of it. Greenhouse gases trap heat in the atmosphere and make the planet warmer. But how exactly does it work? Today, we'll be looking at the greenhouse effect, how it's changing the climate, and some of the ways we can respond. Let's start at the source, the sun. All celestial bodies constantly emit waves of energy called black-body radiation. Objects with different temperatures emit different kinds of radiation. The sun is hot enough to emit high-energy waves called visible light. The Earth emits radiation too, but it gives off a weaker kind called infrared. This means that energy coming into the atmosphere and energy leaving are different. Energy comes in as packets of visible light, but it leaves as waves of infrared. This is important because different kinds of radiation interact with the atmosphere in different ways. All molecules have different ways they can vibrate or rotate. These are called modes. Molecules jump from one mode to another, that is, they start vibrating or rotating, when they absorb specific amounts of energy. If a packet of radiation with exactly that much energy hits a molecule, the molecule can absorb that radiation, but if the wave has too much or too little energy, it'll pass right through. Now, it turns out that most of the Earth's atmosphere is immune to the visible light coming from the sun. Those waves have too much energy to cause any molecules to switch modes, and they pass right through to the surface. But some molecules, like water vapor, ozone, and carbon dioxide, have modes that exactly correspond to the low-energy infrared waves coming from the Earth. These molecules, called greenhouse gases, absorb most of Earth's outgoing radiation, and some of it gets released back toward the surface. This extra energy keeps the planet warm, and we call it the greenhouse effect. Now, some greenhouse effect is normal. Without it, the Earth would be a frozen rock. But over the past 100 years or so, humans have put more greenhouse gases, mostly carbon dioxide, into the atmosphere. This doesn't change the amount of energy the Earth gets from the sun. Remember, the sun's energy passes right through the atmosphere. But more greenhouse gases means more outgoing energy gets trapped and reflected back to the Earth. And this extra energy is causing the planet to slowly get warmer. This heating, called global warming or climate change, is causing the sea levels to rise, threatening agriculture, and might even be worsening natural disasters like hurricanes. Since greenhouse gases are causing global warming, the only permanent solution would be to stop putting them in and start taking them out, but that's easier said than done. Cutting back on pollution means cutting back on the fossil fuels that make modern life so convenient, and while there are ways to pull carbon dioxide out of the atmosphere, they don't remove enough to make an impact, or they're just too expensive right now, and nobody wants to pay for them. So how are we going to deal with global warming? Without limiting the carbon dioxide in the atmosphere, we can't change the amount of energy reflected back to the Earth. But what if we could change the amount of energy reaching Earth in the first place? This is an idea called solar radiation management, and it belongs to a family of ideas called geoengineering, which is the name for any man-made effort to change the climate. Here's how it works. After big volcanic eruptions, the temperature of the whole planet cools down by just a little bit for about a year, because some of the particles from the volcano reflect a little bit of sunlight back into space. With a little human ingenuity, we might be able to replicate this effect, only using planes instead of volcanoes. The Intergovernmental Panel on Climate Change recommends limiting global warming to well under 2 degrees Celsius by the end of the century, but if we don't take any action between now and then, we're more likely to see about 4. In a worst-case scenario, we could try to use geoengineering to prevent those 2 degrees of extra warming. With a quick model of the global energy balance, and a little bit of math, we can estimate that reducing the surface temperature by 2 degrees means reflecting about 7.5 extra watts of sunlight for every square meter on the Earth. To do this, we'd need about 10 teragrams of sulfur, or 22 billion pounds. And that's geoengineering. By injecting 22 billion pounds of sulfur into the stratosphere every year, we might be able to stave off global warming until we find a permanent solution. So, the million-dollar question. Is it worth it? For starters, geoengineering can't stop global warming, only delay it for a while. It's like taking a painkiller for a broken leg. It doesn't deal with the source of the problem. It just eases the pain while you get to the hospital. Unabated climate change could cost trillions by the end of the century. Geoengineering would cost much less, probably tens of billions a year, but that's still a lot of money. Who would pay for it? 22 billion pounds a year is a lot of sulfur, but it's a fraction of what we're already polluting, about 10%. Even so, more pollution is bad for public health. Is that better than climate change? Who even gets to decide anyway? Finally, if geoengineering buys us a few more decades to figure out global warming, then what's to stop us from just putting it off again? These aren't questions we need to answer right now, but we will need answers eventually. And if we don't get serious about global warming, eventually might come a lot sooner than we think.